Hello, this video will cover how to solve for the range of a rational function given a slant asymptote, something like this. So we don't really have to cover how to find the domain of such function because basically we only have for um, for the domain we only need to rely on the zeros or rather the vertical asymptotes of the rational function, like with any rational function. So something like this. But if you'll notice over here, we can't really pinpoint certain values on this curve, which could give us like certain ranges that we can implement on our range. We can't, basically, we can't really identify or exactly pinpoint just by looking at this graph, this point over here. So for our strategy in finding the domain, or the range rather, of such a rational function, what we'll do first is write this rational function in a quadratic equation, or write it as a quadratic equation. So this form over here, ax squared plus bx plus c is equal to 0. And then we will use the values that we get for a, b, and c. Let me just rewrite this. Pardon. Yes, as I said, we'll be using the values of a, b, and c and rewrite this in the discriminant form. So b squared minus 4ac, and we'll set this to 0. More on this later. So for now, let's focus on rewriting this as a quadratic equation. So it's just the basic algebraic stuff. What we can do first is multiply both sides by x minus 3. Obviously, x minus 3 will be cancelled on this side, and on this side, y will be multiplied by x minus 3. So something like this. And then we can distribute y to x minus 3. Oops, I have to distribute it actually. So this will become xy minus 3y, and then the right side is remained as such. All right. And then now we can put all of these terms in one side and have the other side equal to 0. But as we do that, we can already group like terms. So say, for example, x, y, and x. So this will become as basically we'll just transfer or transpose these two terms to the other side. So this will become negative. So we can write this as x, this x over here, and then minus xy. And then this 3y will become positive. So plus 3y minus 6. And yes, this is equal to 0. And then we can factor out similar terms. So for this part, this will become, yep, 1 minus y x. So basically, the expression for b is 1 minus y. And then for c, basically we'll just have to rewrite this part because this alone is already c. So there's that. So now we already have the values for a, b, and c. So our a over here is 1 because x squared has a coefficient of 1. For b, it will be this one, 1 minus y. And then for c, it's this part, or this expression. So now we have the values for a, b, and c. Now we can just disregard this entire part. Oops. Oh, come on, bro. All right, so we've accomplished step 1. So now we can now go ahead to step 2. So basically, notice that a while ago, we have the rational function in this form. However, we cannot proceed with that in determining the values to represent the ranges or the range of this rational function. Because remember that the ranges represent the y values that are part in a way of a function. Because the domain represents the x values, so the ranges represent the y values. And we can't really use an expression that is expressed with with a variable of x, essentially. Because again, the range represents y values. Notice as well over here that our values for, or our expressions for a, b, and c are expressed in terms of y. Therefore, one such way to go about this is writing this form or using these expressions and writing them in this discriminant form. All right. So for b squared, it's basically this one. So 1 minus y b, or squared. And this is a minus 4a, which is 1. My, did I say did I say some minus? If I did, then my bad. I meant to say multiplied by, or times. So we have 4 times a times c over here. And then this is equal to 0. So we just have to expand this, basically. Let's start off with um, the square, the squared expression. So this is, so expanding this, we will have 1 minus 2y plus y squared. And then we can distribute 4 to 3y minus 6. So this will become negative 12y, or minus 12y plus 24 is equal to 0. All right? And then we can go ahead and group, or before that, notice that we have a y squared and then y. Basically, it's sort of like we're going back to the quadratic equation form, or we're about to go back to a quadratic expression. Only now it's written in terms of y, which again, that's what we want because we want to find the range of this function. So, well, same as before, we'll just have to group like terms. So we have 2y, negative 2y and negative 12y over here, right? And then 1 and 24 over here. And then combine like terms. So negative 2y minus 12y. This becomes negative 14y. And a 1 plus 24 becomes 25. So there you have it. So there you have um, a quadratic equation written in terms of y. And now all we need to do is just factor this out. And in this case, we can just use the quadratic formula. So just pause this video and have it go for yourself. Have a go with it. So basically, the values that we will be getting here must be 7 plus or minus 2 raised to negative 6. And obviously, this represents two values, 7 plus 2 square root of 6 and 7 minus 2 square root of 6. All right, let's go back over here. Right, so notice that the intersection of these two asymptotes roughly point at about 7. Or actually, they do meet at 7 in terms of the y value. This point is actually 3 comma y because obviously the x value of this asymptote is equal to 3. It just so happens that they meet at 7 in terms of the y value. So anyway, they meet at y is equal to 7. And if you notice here, we have 7 in this value. So what we can decipher here is 2 square root of 6 is like the sort of distance from this point over here, wherein its y value or its y coordinate lies at 7. So we can say that this value here and this value here, these two values have a distance of 2 square root of 6. Um, anyhow, we can finally write the range of this formula, or this function rather. So obviously notice here that the function does extend towards negative infinity and also extends towards positive infinity. If I can get this to, okay, there you go. Use his hand actually. So again, notice that this function passes through and extends through negative infinity and positive infinity. So we'll have to note that down. But we also have to take note of these points over here, which are these values over here. So our range will be negative infinity, comma. So the value to be paired up with negative infinity will just have to be this one, the one with a minus 2 square root of 6. So 7 minus 2 square root of 6. And do note that this is included in the set because obviously it represents this point over here. So there's that. Oh, let me erase this first. All right. And obviously union because we have this other part to deal with. And then this point over here represents the positive value or the positive counterpart rather. So that would be 7 plus 2 square root of 6. Obviously, again, this value is included, comma positive infinity. And this is the range of this rational function that has a slant asymptote and just a vertical asymptote as usual. So that's all for solving the range of a function that has a slant asymptote. I don't think it's a topic that's usually taught in senior high school here in the Philippines. I recently graduated from senior high and we were never taught how to get the range in such a case like this. I think only some schools do. So yeah, I thought if you guys are facing the same problem, then I hope this video could help you. So yeah, that's about it. Thanks for watching and I'll see you around. Goodbye.